Welcome to my channel, and let's look at integration of the product of sine and cosine part 2. In our part 1, we looked at integration of sine of x raised to n times cos of bx raised to m, where the exponents n and m were either all of them odd or one of them was odd. In the current video, we're looking at the same integration of sine and cosine products, but this time the exponents n and m must all be even. So if all the exponents are even, then we follow the methods that I'll show in this video. Now, so for us to do integration of sine x with an even power or an even exponent times cos, let me say x with another even exponent, then we need to know some identities from trigonometric ratios, the one that was learned in trigonometry. So some of the formulas that are very important in trigonometry that we'll be using are the following. Of course, you know how to get these formulas. You know that if you have cos of 2x, we are using the double angle formula. You know that this is the same as cos of x square minus sine of x square. And of course, you can write everything in terms of sine. You can change this. You know that cos x square is 1 minus sine x squared. So that means that cos of 2x will be the same as 1 minus 2 sine of x squared. So when you make sine x squared the subject, then what we have is that 2 sine x squared the same as 1 minus cos of 2x, and that means therefore that sine of x squared is the same as half 1 minus cos of 2x. So what I mean is these formulas are important and are derived from the double angle formulas. So this one is derived from the double angle formula, the same to this, and the same to this. We are deriving them from the double angle formula. Of course, this part C, we know that sine of 2x is the same as sine x cos x plus sine x cos x, which means this is the same as 2 sine x cos x. When I make sine x cos x the subject of the formula, it means I must divide also by 2. And so that gives me this. That sine x cos x is the same as a half of sine 2x. Now, so these formulas are important to us because whenever you're integrating the product of sine, and if the power is even with cos and the power is also even, whenever you're integrating this, we'll be writing this in this form and write this in this form and then carry out integration. So let's look at examples. The first example, we have these examples, as well as all of them. I want just to begin by this. This is simple. So I must write sine x. This is sine x squared dx So I must write this time x in the form shown above. And the form shown above, we've seen that sine x squared is the same as 1 minus, let me say, a half cos 2x. So where there is this, I'll just write its equivalent. That's what I've done. That the integral of sine x squared dx is the same as the integral of this. So you can opt to take a half outside the integral sign or just multiply inside. And when you multiply inside, what you will have is the integral of a half minus a half, then cos 2x dx. Then just integrate. The integral of a half dx is a half x. And the integral, this half is a constant, times the integral of cos x is cos 2x. This cos 2x is sine 2x divided by 2. Then plus constant of integration. So when I write the final answer, what I have is a half x minus 1 over 4 sine 2x plus c. So that becomes my final answer to that. Now let's look at the next example. And the next example we're given cos of x raised to 4 dx, and we are asked to integrate. So we must remember that cos x raised to 2 is a half into 1 minus no plus cos 2x. But what do we have here? What we have is cos x raised to 4, and this is just the same as cos x raised to 2 square. So it means I must square this. I must square this. So this is the same as a half into 1 plus cos 2x, everything is squared. Everything is squared. I can want to open this bracket in a square. For instance, if I open this bracket, this is what I have, a half plus a half cos 2x, then I square it. Squaring means I multiply by itself. So let's just do that. Let's just multiply by itself. A half plus a half cos 2x multiplied by a half plus a half cos 2x. Let's just multiply that. So a half times a half will be a quarter. Then a half times a half cos 2x, it will be a quarter cos 2x. What about this a half cos 2x times this a half? It will again be a half, now quarter cos 2x. What about this times this? It will be plus a quarter cos 2x square. So you notice that these ones can be added together. And when you add together and combine with all this, you have a quarter plus a half cos 2x plus a quarter cos 2x square. So that's what I have here. That's what I got. That's how I got this. That's how I got that. So I will just square this where I said the only trick was at this point, and it's not even a trick once you discover that cos raised to 4 x is the same as cos x raised to 2 the square of this. It becomes very easy. And then you just go back to the formulas we had above and get what this one was, and then square it. Okay, so we are now ready to integrate. Once it's at this point, it's easier, but look at this. We cannot integrate this until we replace it again using the above formulas. We must again use the above formula to replace that so that we can integrate it. So that's my next step. My next step, I'm doing that. And I know that what I've given is, of course, x squared is a half into 1 plus cos 2x. But now what I want to find, what about this? What about that? So, because it's 2x here, raised to 2. This will be the same as a half into 1 plus cos 4x. The same as that. And that is what you're seeing here. That's what you're seeing here. So that instead of this, a quarter is still there, the quarter is still here. I've just replaced this with its equivalent and its equal to this. So it's now very easy that we just open these brackets, and after that we'll do the integration. So when you open the brackets, a quarter, we have this a quarter. Just right here, we have this a quarter. And then we have a half cos 2x. Now let's open this bracket. This a quarter times this will be an 8. 1 over 8 times a 1 over 8. And then 1 over 8 times cos 4x will be 1 over 8 cos 4x. This and this can be added together to give us 3 out of 8. A quarter times 1 over 8 will be 3 out of 8. And then I have plus a half cos of 2x, then plus an 8th cos of 4x. And that's what we see here. It's now easy for us to integrate this because we no longer have the powers. The exponents are no longer there, so we can do the integral. And of course, we now have to integrate this because we had looked at how to integrate trigonometric ratios earlier in our other video. So let's just integrate. Of course, remember you have limits. So the integral of 3 over 8x, no, 3 over 8 dx is 3 out of 8x plus the integral, this a constant is a half, times the integral of cos 2x is sine 2x divided by 2. Plus 1 over 8 is a constant. The integral of cos 4x will be sine 4x out of 4. Then plus constant integration. Then put the limits which are 0 to pi out of 3. Of course, this is 3 out of 8x, and this is 1 out of 4 sine 2x. And this is 1 out of that 2 sine 4x. Then put the limits. I've done that. I put the limits, and when you put the limits, what you get is approximately 0.5821421 when you put this limit. Now let's look at this other example. The power is even, so we can use our method. The power is even, so it makes it very easy for us. So let me just clear this. But remember, what we have as our formula is that sine square of x would be a half into 1 minus cos 2x. That's the formula we had at the beginning. But what we've been given is this. What we've been given is sine 3x squared. What is this equivalent to? This is equal to a half into this 1 minus cos 6x. So this is very important. It's what I'm used to. So that the integral of this is the same as the integral of this. So the integral is the same as integrating that. That's what I have. So just multiply a half inside. When you multiply a half inside, you have a half minus a half cos 6x dx. And now just integrate this a half. The x gives you a half x. And this negative I have the constant. So what do I have? What do I have? This is the half x minus a half multiplied by the integral of cos 6x will be sine 2x divided by 6 plus constant of integration. And so simplifying this, you arrive at this. It's now very easy for us because we now know the trick, where the trick is. Let's look at this other example. And the example is this. Look at this. Good. We go back to our formula. Our formula says that the cos of x raised to 2 would be a 1. Now let me say half into 1 plus cos 2x. But what do I have? This. I also know that cos 2x squared would be a half into 1 plus cos 4x. What about this? This is cos 2x squared. So the means that I square it means that I must square a half plus a half cos 4x. I must square this. But that's what I did here. That's what I did in this step. That's what I did in this step. That's what I did in this step. So you squaring this is very easy. Just multiply it by itself. I have a half plus a half cos 4x multiplied by a half plus a half cos 4x. So a half times a half will be a quarter. A half times a half will be a quarter again there. Cos 4x. This times that will be a quarter. Cos 4x. And this times that will be a quarter. Cos 4x squared. These two together. And so what we have will be a quarter plus a half cos 4x plus a quarter cos 4x squared. And that's what I have here. That's what we have at this point. A quarter plus a half cos 4x plus a quarter cos 4x squared dx. I can see I still have a power here, an even power. So again, we have to change that. So we have to substitute it by its equivalent. What we know is that cos square x is a half into 1 plus cos 2x. But what about this? What about cos square 4x. This will be the same as a half into 1 plus cos 8x plus cos 2x, 8x. And this what you see here, the quarter is still here, but this I've changed it, I've written its equivalent, which is a half into 1 plus cos 8x. So that what follows, just to simplify here, and when you simplify, now this a quarter, you have that half cos 4x. What about here? This is an 1 over 8 times 1, which is 1 over 8. And this is 1 over 8 times cos 8x, which is 1 over 8 cos 8x. This a quarter plus 1 over 8 gives you 3 out of 8. And plus a half cos 4x. And plus a quarter, no, 1 over 8 cos 8x. And it's this that we're seeing in this step. So now easily, we no longer have the exponents here. We no longer have the exponents. That means we can now just integrate direct. The integral of this dx is 3 over 8x. And the integral of this, so that is 3 over 8 x. And the half there is a constant, but the integral of 4x, 4 cos 4x will be sin 4x divided by 4. And 8 there is a constant. The integral of cos 8x will be sin 8x over 8. Then plus constant integration. So what that gives me is 3 over 8x plus sin 4x out of 8 plus sin 8x out of 64 plus constant integration C. And then this one was a definite integral. That means we must insert our limits. We must insert our limits, and that gives us this. Let's do the last example. We have now the product of two of them, the product of sine and cos. And what is important is that the powers are both even. That means we must use our formulas above. We must write the equivalent of this and the equivalent of this. And you can see the equivalent of this is a half into 1 minus 2 cos x, and the equivalent of this is a half into 1 plus cos 2x. So this a half times this a half gives a quarter. So what we have there is a quarter, of course under the integral sign, and you must remember the limits 0 to pi out of 8. Now what remains is for us to multiply this 1 minus cos 2x times 1 plus cos 2x. So what do we get? Under the integral, that is a half, a quarter into, this is a difference of squares. The difference of squares, when you multiply that, you just get 1 minus cos 2x squared. The difference of squares. So multiplying this through, you arrive at a quarter minus a quarter cos 2x squared dx. You cannot proceed and integrate before you change this as a power there, as an even power. So you must write the equivalent. And the equivalent of this is a half into 1 plus cos 4x. And that's what I wrote here. So I have this a quarter and this a quarter, but instead of this, I'm writing this. So what happens thereafter? So let's just open the bracket. Just open the bracket here. This will be a quarter. Of course, under the integral sign, and remember the limits, minus this is 1 over 8 times 1, which is 1 over 8. And there's this minus here, 1 over 8 times that, so the negative 1 over 8 cos 4x. So what is this? What is a quarter minus 1 over 8? Of course, the LCM is 8. So that will give us 1 over 8. Then minus a quarter 1 over 8 cos 4x. So this 1/8 minus 1/8 cos 4x dx can now be integrated. That's what we have. So the integral of this will be 1/8 x and negative 1 over 8 is a constant, and the integral of cos 4x will be sin 4x divided by 4. So that gives me negative 1 out of that 2 of sin 4x. And then we put the constant of integration. Put the constant of integration. And this is what we arrive at. If we have to put the constant of integration, this is what we arrive at. Then maybe let's just do it and see. Let's do it and see. So when I put pi over 8, I would have 1 over 8 times pi over 8, then minus 1 out of that 2 sine 4 multiplied by pi over 8. Of course, this will give you the one here. This is like sin 90, which will be 1. And this is minus, when you put 0 here, it will be 0. And when you put 0 here again, this will be 0. So minus 0. So what do we have? What we have is pi out of 64 minus 1 out of that 2. And the LCM of the 64. And this will be pi minus 2. That's how I arrive at this. Or you may want to substitute pi with its equivalent. And this pi is on your calculator. So with your calculator, just press pi. You can even open the brackets. Press pi. And then minus 2, close the brackets, then divide by 64. And that will give you this one. Of course, there's another method that I used to do the same. So the other method I used was that this can be written this sin x plus x squared. But we know from the formula that we had above, we had that the sine of x cos of x is the same as a half sine of 2x. The same as a half sine of 2x. So that's what I wrote. That instead of this, I have a half sine of 2x, and then you square it. When you square this, you get a quarter sine of 2x squared. And of course, this we know, since it is squared, this one should be replaced with into 1 minus cos 4x. Since it is squared, we must replace with this. So this one I got, a quarter is here, then times this. So that gives you 1 over 8 minus 1 over 8 cos 4x. Now this can now be integrated because you no longer have a power here. So this is just 1, the power is 1. So this will give you 1 over 8x minus 1 over 32 sin 4x, and then you put constant integration, and you get the same result. And that is how we do integration of product of sine and cos when the exponents are both even.